All right, friends and neighbors, welcome back to another networking video. I think we're going to conclude the series on home networking, but before we do, we've got to ask ourselves what to do with all those coaxial cables. Now, you may be still on cable TV or cable internet. You may be switching to fiber like I just did. But no matter where you are, we ought to answer this question: what are we going to do about these cables? And I'll tell you why I'm asking the question in just a minute, because we have an opportunity here. Now, before we dive into, what you can do with your infrastructure, let's talk just a little bit about traditional television versus cable. So there was a time, right, when everybody had a TV in their house and all of the signals came to the TV. They were all broadcast out into the ether. They were all RF signals. And your TV picked up all of those broadcast signals. Now, one of the key ideas here is that the modulation techniques that were used were a little bit different than the modulation techniques used today. And so every TV had an antenna attached to it of some kind. And your local broadcast television, for me it was 3, 5, and 9, and then channel 24 for public broadcasting. These were your standard television channels, all broadcast through the air, all on particular frequencies. And then your TV tuner actually was tuning to a particular frequency. Kind of cool. Now, with the advent of cable television, or I'll just say cable connectivity at this point, all of that sort of changed. Now, the idea for cable connections or coaxial based connections, by the way, when I say coaxial based connection, I mean something that looks like this, right? This is a very, very different cable than the unshielded twisted pair that we're used to dealing with. And so we use these kinds of cables for cable television, but also antennas of all kinds. And it's just the impedance of the cable that's a little bit different. Okay, so the idea dates back to the 1950s, but it actually started to catch on in the 1960s and the 1970s. And the story of cable television is actually very, very cool. It has to do with areas where the broadcast was not able to be seen very easily. So the mountains, valleys, places like that, I think it was the Allegheny Mountains, they got the idea that they said if we put an antenna way up on top of the mountain or on top of the hill and we run a cable down to everybody and then split it off, then everybody will be able to see what in the world is going on in the broadcast world. So I've included a couple of links here to the story. I'll put those in the show notes too. Really, really sort of interesting. By 1980, there were around 16 million subscribers. And so you can see that once the idea started to catch on, folks started to realize they didn't have to rely on an RF broadcast through the air. This actually is kind of cool. And so cable started to beat up on traditional TV. Now, what is a cable TV channel? Well, as I just said, when we were going through broadcast television, the tuner on your TV actually changed the characteristics of the electrical circuit and tuned into a particular frequency. And that frequency was the carrier wave, which the TV modulated or demodulated, I should say, so you could see what was broadcast. A coaxial cable actually carries what we call a composite signal. There are a whole bunch of carrier waves that exist simultaneously on the broadcast media, on the coax cable. And so when you tune into a particular station, you're doing the exact same thing. You're figuring out the carrier wave that you want to watch, and then you're demodulating the data that's on that carrier wave. TVs did not understand cable television signaling. And so what we needed was a box that took care of the signaling or the demodulation for us, and then we pumped it back to a TV. Again, that was a pretty stupid device. So for a long time, there were no TVs that had a cable interface, and then TVs started being manufactured that actually had the coax interface. I still remember buying a VHS tape player or a VCR that you had to tune in to figure out where all the frequencies were, and then you could just hit the remote or hit the button and get the right channel. So a couple of details about a cable TV channel. They're about 6 megahertz wide. Now, there are some standards that push them out to 8 megahertz, but they're in general 6 megahertz wide. And that 6 megahertz wide channel, and if you compare that to a 20 megahertz wide 802.11a or G channel, right, that gives you the idea of just how big it is. That 6 megahertz includes the video and the audio subchannels. Now we've got a bunch of standards that go along with this, right? How things are going to look, how things are formulated, and then how things are transmitted. And so these include NTSC, PAL, and the DOCSIS standards that we always hear about when we're talking about cable modems. So your cable carried a whole bunch of these 6 to 8 megahertz wide channels. And when cable internet came out, it was just one more channel, or a channel that was allocated to data. But that channel was wider than dial-up networking, than DSL at the time, and so it was kind of a big deal. And so cable internet also started to catch on, but it's very fun to remember that it was really just, initially anyway, one more channel on your set of 57 channels, and there's nothing on. So cable distribution had massive capacity. It still does, but of course today it's running up against fiber. So what did a typical setup look like, right? You've got your ISP coming in. And in this case, I'll include the ISP is not just the internet service provider. It's the cable television provider, of which the internet or the data is just one of those channels. So it came in to your house and you split it. So here is an example of a splitter, right? It's a very simple device, but you've got one input and then a series of outputs. One of the outputs went to your cable modem, and the other output went to your TV. Why? Because your TV didn't care about cable internet at the time. So you wanted to send it to the cable modem, and the cable modem's job was to find that one channel and demodulate that channel, and then, well, in this case, modulate, right? It was up and down, so that you could do your data. But all of the rest was just the normal cable television channels that went out to your set-top box, your VCR, and then to your TV. Now, some TVs also had an antenna attached because there were some stations that you wanted maybe that weren't covered by your cable television, right? Maybe you didn't get local programming, and so you might have had an antenna that was attached to your TV as well that allowed to get you those local broadcasts. But of course, what's life without more changes to the system that we get to use? So in 2009, the US, anyway, I don't know where the rest of the countries are in all of this, various states have changed, but the US changed to a digital broadcast system. And what this means is that all of the television that was broadcast before 2009 was traditional analog modulation. And to put more data out there, more capacity, the change was made, or the decision was made to change to digital modulation or digital channels on the broadcast. Now, all of a sudden, your TV now doesn't understand what's being broadcast through the air. And so we needed another set-top box to be able to decode those channels. So now your antenna is picking everything up, but your TV has no idea how to interpret it. And so you would put this box in between the antenna and the TV, and presto, your TV now gets the data that it's used to receiving. Now, there was a very funny series of videos that were done about trying to explain this to people, how everybody had all of these TVs and how you were going to have to convert your TV to be able to understand the local broadcast, or really any broadcast that was out there. So I found the video out on Anteater Dan. That's his YouTube channel. I'll put this in the show notes too. A very, very funny video of somebody trying to figure out what it was like. And so if you didn't have any familiarity with this, or you weren't, sort of savvy in the ways of cables and everything else, it was a struggle, so much so that the initial push in 2009 was pushed back to later on in that same year. So today, where are we? How have things changed? Well, there's some questions here, right? Uh, if you've got a coax hookup, how many of those cable television programs do you still watch? So for a long time, I was watching, the streaming media, right? We'll say Netflix here. So you're watching Netflix, and then you realize, oh, you've also got all of these cable television channels. But there was so much on the streaming services that you kind of go, well, I'm not really watching my cable television programs anymore, except for maybe reruns. And every once in a while, you get the sports that you want. But we came to realize that as long as we could find the content that we wanted, we really weren't watching any of the cable television. And what that meant was that you didn't have to pay for cable television anymore, which was a big deal, right? We're going to save all kinds of money. Well, that sounds really good. It's pretty awesome. But you end up buying up all of these streaming services. I mean, right now, I don't know about you, but we subscribe to 5 or 6 different streaming services. And every once in a while we go, wait a minute, what are we really watching? So there is an impact in dollars. We saved all that money getting rid of cable television only to spend the same amount of money watching streaming services. And then there were other programs like, are you renting gear from the cable provider, right? Do you have a DVR? All these things are no longer really necessary. Another big change is that television started to get as smart as the set-top boxes. And so the manufacturers were now building in the ability to demodulate the digital signals right into the TV. And so you didn't need all of these extra boxes. So today, we've got not only TVs that are smarter, but TVs that can be hooked up to our networks. And so in the diagram here, I've got your cable modem comes in, and then it goes to your home gateway. And of course, we've just got the TV and the laptop and the PC and printers and Xboxes and whatever hooked right up to the network. So again, why do we need all of this other cabling? The only thing that you need is that cable coming into the building, and then we split it all off. So this brings us to the use of all of that coaxial cable. If you had multiple TVs in the house, then suddenly you've got multiple connections, multiple coax wiring going to all these TVs and sprinkled throughout the house. And of course, you've got the splitter. So now what do we want to use all of that equipment for? Well, here's what we're going to do. Since TVs now understand the digital modulation of the broadcast signals coming through the air, we just have to get to the signals. And for us, we like to watch sports when they're broadcast. A lot of times they're on a streaming service that we don't have, or they're blacked out. So sometimes we can get a hold of the games and things like that that we want. For us, that's, go Bills. So what we're going to do is get a long-range antenna. And for me, that ends up looking something like this. Right? Show you a couple of views there. So this is probably looks quite a bit different than the antennas that you're used to thinking about. But this is an antenna that has, I believe, a 30-mile range. It can pick up signals about that. And of course, you can spend a lot more money on that than you want to. I think I spent about $60 on that one. But you can get an antenna that can really, really scoop up the signals that are a long way out there. And all that you do is hook this up to your cable infrastructure because it's coax as well. Now, a good question is, where in the world do you put that thing? Well, before you start doing permanent installations of any kind, try various places out in your house. Hint, hint, wink, wink, what you're probably going to want to do is go someplace high in your house. So that's an internal antenna. They do have externals. They're more expensive. So this is an internal antenna. I went to the highest room in my house and ran coax up there to see if it would work. And it turned out it did. So what you do is you put the antenna in, and then you have to tune your TV. Your TV has to do a scan of all of the channels. that are now on the coax connection, because there's a really good chance that you're no longer running coax to your TV anymore. So if this is the case, if your coax only goes to your cable modem, right, you can now take all of this passive unpowered coax and run it to the antenna. So I run my antenna down to a splitter, and then I send out the cable to whatever TVs I want to have connected to that antenna. So it's mounted high. I tune the TV, and then you can also fool around with the orientation, right? What's the best position for your antenna? It makes a difference. And after all that, what you should find out is that you have access to not only your streaming services, but also whatever now you can pick up with your antenna. And this really makes a difference for folks that are a little outside of town, because you can shoot all the way down. I'm several miles away from the nearest broadcast center, and I can pick up a lot of stations. And of course, we pick up the games. Now, one more thought about, of course, what's coming. Now we have fiber to the house. So I don't even use my coax connection at all. So all the coax that we had installed for all those years of being on cable television and cable internet are now completely useless, not part of my infrastructure at all. But that's why I decided to see if I could use that to get the broadcasts through the air. The very idea of TV channels is fading away, right? When is the last time you said, well, I'll tune my TV into a TV channel, especially if you're a consumer of streaming services like we are? Now, when you go to optical, right? Optical is beating up on cable the same way that cable beat up on traditional broadcast television. There is a different box now. We still have our home gateway in there, but you now have an optical signal converter, and its job is to take the signaling coming in on the fiber optic and convert it to Ethernet for the rest of your internal network. But there you go. So that'll be the new device that you'll see. Good old coax. Coax has tremendous capacity. It had the ability to provide us with hundreds of channels and a very, very good amount of bandwidth. Coax is protected from outside electromagnetic radiation. It's tough cabling. It's got a braided jacket on it. It's a little bit of a pain to work with and terminate until you get used to it. But now we've seen so many changes to our technology that coax is sort of on its way out, at least in some areas. It's certainly not gone, and it won't be gone for a long, long time. But the way that we receive our television programming, the way that we do streaming services, the way that we do data, the amount of time we spend on computers versus television is really, really sort of amazing. And if you get right down to it, if you start to think about what you're spending money on as far as your machinery at home and your services, right? Are you renting boxes from a cable company? Do you have a DVR at all? What streaming services? Are you paying for cable television? All of these can add up to hundreds of dollars every month in entertainment costs. If you just think about it a little bit, sometimes you're able to recoup some of that, because really you can get a tremendous amount of programming just over streaming services. And now we've added our friend, the digital broadcast. Well, thanks for watching. Thanks for listening. Like and subscribe if I gave you some ideas. And no matter if you're going digital through the air or fiber optic or cable streaming services, may those packets always reach their destinations. Although, of course, now they're coming to you instead of yours going out there.